Hello, my name is Fernando and this is my SEMIC project. I'm going to present it. The title of the project is Multi-Objective Linear Logistic Regression. Linear regression is presented here in this graphic on the left, and the data points are presented by the black dots, and they are approximating of the linear regression curve that has a predictable behavior. Logistic regression is used for classifying data that is represented by the red dots. This is the resume that presents about multi-criteria analysis because it's a very important part of the project. The introduction says that multi-criteria analysis can facilitate the decision-making step because it helps analyzing the various solutions possible for a real problem, and those various solutions are inside a Pareto front. The three mathematical models that were tested with the objective to compare its performance were linear regression, decision tree, and support vector machine. The general objective of the project is to evaluate the performance of logistic and linear regression trained with multi-criteria ideas to compare their performance in machine learning benchmarks. And one of the most important specific objectives is comparing obtained results with benchmark results to evaluate their performance. The materials and methods start by splitting the data points into training data sets and testing data sets. There were 15 sensors, or we can call it features, and they were split into feature raw, that is the data without treatment, the feature difference, that is the distance between the points, and the feature map, that is mobile average filter. And in table 1, we can see the order of relevant sensors that we use it to reconstruct variables y1 and y2. The results here are presented by graphics. It's important to say that the data points should be close to each other, and we can see it when reconstructing y1 using linear regression and decision tree. Decision tree, there's a bigger distance and the performance is lower. When implementing support vector machines, happened some issues and it could only be tested until feature 6. But until feature 6, its performance was okay and very, very good for the data obtained. When reconstructing y2, linear regression had a similar results to the other, just like decision tree and support vector machine. The test with support vector machine could not be finished. They were only done until feature 6. One important detail is that the values must be similar on any model and when reconstructing both variables using the same model, and it was for the three mathematical models. Linear regression had a better performance than the others. Decision tree was the second best, and support vector machine also presented a good performance, but lower than the others. Final considerations. Linear regression performance was better than the others. Multi-criteria analysis is an approach that may help on achieving better results, especially on industrial fields, and the models that achieved better responses were linear regression and decision tree. Thank you for your attention.